Now based on this short circuit test, so what we have seen in previous classes, so here give the rated current. So here the IC tip switch, okay. So this is the IC TP switch and R phase, Y phase, B phase, 3 phase supply, and let us this nameplate details is equal to V is equal to 410 volts, ISC is equal to rated current is equal to 8.67 amperes, okay. Then this is for example 5 HP take it. Now in this case the rotor is blocked with the help of the belt with springs, and close the ICDP switch and vary the variac such a way that when ammeter indicates the current of 8.67 amperes, then stop the variation of the variac, then take the voltmeter reading, take the ammeter reading, take the W1 and take the W2. After taking these 4 readings, comes to the variac comes to the 0 position, open the iron clay triple pole switch. This is a procedure for AC test, similar to the short circuit test on transformer. Okay. After taking these readings, now we are going to do the calculations. What are the calculations we are going to do it? Now, so let us, what is the salient mass? Rotor is locked by means of brake test, brake. So therefore, it is called blocked rotor test. It is a rotor is blocked, it is not in a movable position. Then rotor windings are short circuited at slip rings in case of slip ring induction motor. Now apply the reduced voltage to stator terminals up to 10 to 20% of the normal voltage, sometimes 20 to 30% also based on the motor. But you remember that don't concentrate on percentage, you concentrate on ammeter reading only, rated current only. It may be adjusted that the full load current flows in the stator with help of variac slowly varying. When the rotor is blocked, what is the rotor speed is equal to 0. At that condition, the slip is equal to 1. The equivalent circuit of motor is exactly like a transformer since the short circuited secondary. Then what is the equivalent circuit diagram? So the equivalent circuit as follows, that is equal to, so VSC from the voltmeter, ISC from the ammeter, values already we known taken. Then WSC be the total power input from the W1 and W2. So that is a WSC. So with what are the wattmeter reading? 1 watt of the wattmeter, 2 we taken with multiplication factors and with equal to the WSC. That is equal to root 3 VL IL cos phi, 3 phase powers equivalent. From that one, so I am going to calculate, so cos phi SC power factor under short circuit condition. So previously we calculated, what is that one? We know that the cos short circuit condition is equal to, that is a wattmeter readings divided by, so you know that 3 phase, that is equal to, already we know that. So similarly, so root 3 and VSC and ISC. Okay. So from this one I am going to calculate this value cos phi SC. Okay. Once we know that, so what is the VSC, ISC and WSC and cos phi SC, no load, the full load short circuit condition, this one. From this one I am going to calculate the parameters. What are the parameters? This is the parameters of this one. So Z01 refer to the primary. Okay. So, let us see that one also. This is the, our aim is to find it. What is the R01? What is the X01? I am going to find. This is the voltmeter reading, this is the ammeter reading, this is the, that is equal. So, Ws from the wattmeter readings, from this one, this one, this one, this one will gives to find that this value. Okay. So, how to find that one? So, similar to previous case. Now, the total resistance as referred to the primary side. So, here we know that what is happened, what is the diagram. So, we take in the diagram previous case. So, here from this one, that is equal VSC, this is equal ISC, this is R01, X01. Okay, refer to the primary side. So, both equal to Z01. Now, from this one, so we are going to calculate VSC, this one. Okay. Now, I want to know that what is the values. So, what is the values? I am going to go to R01. So, R01, that is the value is equal. So, we know the impedance triangle. What is the impedance triangle? So, here this is equal to phi SC, R01, X01, Z01. Okay. This is a cos phi SC. From this one, so R01 I can, this is a Z01, so I can write it. What is that one? Z01 into, I want the R01, that is a cos phi SC. So, we know the, I calculated from the cos phi SC, and Z01 I require these values. Okay. What is, how we are going to get Z01? Z01 I can get it. So, what is the Z is equal? Impedance, that is equal voltmeter reading VSC by ammeter reading ISC. Okay. Voltmeter reading by ammeter reading. I am going to the Z01, and cos phi SC already calculated. So, that is the cos phi SC. So, we know that cos phi SC is equal, that is equal WSC divided by root 3 and VSC and ISC. So, from ammeter reading, voltmeter reading and wattmeter reading, I calculated cos phi SC, and at the same time, so voltmeter reading, ammeter reading, I am going to the, this is the impedance value, and this impedance value, this value I am going to get the R01. Okay. So, I got it, this R01. Similarly, I am going to get it X01. So, what is the X01? In this case, X0 I require the, this value. So, X01, so that is equal to, I can X01, I can write it, this value I want it required. So, that is equal Z01 into sin phi SC. I know the sin phi SC, I know the Z01, I calculate from this one. Okay. You know the phi SC, I am calculate the sin SC, then I am going to get it 0, 1. Now, I got it R01 and X01. So, these two parameters we got it. Okay. So, this is the two parameters referred to the primary side. Now, what is this one R01? So, R01 further we know that R01 is equal to, that is equal R1 plus R2 dash. What is the R2 dash? R1 plus R2 by K square. What is the K square? Transformation ratio, you know that. So, from this one I am going to calculate this total value R01 value X01. Similarly, X1 plus X2 dash, that is equal to the this value. Okay. So, these are the two parameters we are going to find in this case from rotor, block rotor test. Similar to the no load test, we are going to draw the input voltage versus power input and current. So, you can see here. So, R01 calculated, Z01 is equal similarly. So, that is we calculated total reactance required to the stator. Okay. So, now we can draw this one. Here what is happen? Input voltage from the voltmeter, and this is the from ammeter, this is the from WSC. So, if you draw on the voltage versus the current, it is a linear, whereas the power is equal non-linear. This is called I square non-linear, where this current is equal linear value. So, this is the graph between the input voltage and current and power. Okay. So, this is the AC test. Now, coming to the last test, so where we require the we got it. What is the value we got it? Here R01 is equal to R1 stator resistance plus R2 dash. Okay. So, that is equal to R1 plus I require the R2 by K square. Okay, transformer ratio. R1 stator resistance, R2 is the rotor resistance. So, what is the value of R1, R2? How we are going to find it? So, simply I can use the VI method to find the resistance. VI method means by applying the Ohm's law. Okay, so what is the Ohm's law? So, any resistance, this resistance, the coil, and I will give the some DC supply. I connect the one ammeter, I connect the one voltmeter, and I will give the voltage by variac DC voltage. Then what will happen? So, by changing the voltage, so voltmeter will show some reading and ammeter also showing the some reading. Okay. Then what is the V by I? Because the DC, the R is equal to V by I. So, we by changing the this variac, I am going to get the different voltages, correspondingly I am going to get the I zeros, then correspondingly I am going to get the R this. So, average it, you are going to get it what is the resistance of this winding without any leakage reactance. Okay. That is the main aim of this test. So, from this one I am going to get this value. Okay. So, it is necessary to determine the value of R2 dash at the same time. So, to find out the shape of the speed torque curve, it is a very essential to know that what is the curve shape of this speed versus torque. Okay. At the same time, it can be used to find that slip for pull out condition at which the pull out the maximum torque condition takes place. Okay. For this purpose, the stator resistance R1 can be measured by passing a DC current through the stator winding, and the ratio of a DC voltage across the phase to the DC current gives to the resistance, that is called R is equal V by I, that is a voltmeter reading by ammeter reading in a simple circuit. Then I am going to get that the resistance. Okay. So, this already you calculated this test. Okay. So, we will see that also. So, here now the stator resistance test, what to do? So, you connect the, we take the one phase. Okay. So, here you take that any one phase, you take it. Okay. From this one you can connect here, and here you connect the one DC supply with variac. Okay. Now is connected to one ammeter here. Okay. Now you connect the one voltmeter also here. Now change this variac. What is happened? So, here the winding is between the two phases. Okay. Now, voltage plus minus voltage, you give it the voltmeter reading and ammeter reading, and this is the R values, you take it. Initially I give the some voltage, for example 0 to 12 volts range. give the 2 volts. Correspondingly, you know that this is connect the 0 to 1 ampere MC meters, you give it 0 to 12 volts, or you can take the 20 volts MC meter. Okay. Now 2 volts you give it, then correspondingly what is the current? 0.1. You take the this value, R is equal V by I. Okay. And serial number 1. Serial number 2, you take the 4 volts. What is the current? 0.2. Then 3, 6 volts. What is the current? For example, 3.3. So correspondingly, you are going to get these values. Similarly, you take the nearly you can take the 10 readings. Then you are going to get these values. You are going to this readings and you calculate these values. Finally, you are going to get it, average it. Then if we are going to get the average, for example, this may be 0.864 ohms. So this is the value of R1 plus R2 is equal, we are going to get it the, so for example 0.864 amps ohms. Then I require the equal, I suppose the two phases are equal, that winding may be balanced condition. I require the R1 is equal 0.864 by 2, I am going to get nearly 4342 ohms. This is a R1, I am taking this reading. Okay. This is the test you are going to perform to find any unknown winding resistance with the help of VI method, voltage and I method. This is a very familiar method to find unknown resistance in a given coil. So already you are done in secondary level. Okay. So this is a simple test. But performing this test, you are going to find that what is the resistance. Okay. Now, okay, these are the already we know. The stator, therefore, the rotor resistance as referred to the stator is equal R2 dash is equal R naught 1. We know the already, we have seen. So this value, we got it. We known this value from the no load test, that is the VI method. Okay. So we are going to calculate the R2 dash. So there is no easiest method to separate the two reactances. So we know that R naught 1 from meters and R1 from VI method and R2 dash can the R naught 1 minus R1. I am going to get this resistance. But whereas similarly, that is I require the X naught 1 is equal to X1 plus X2 dash. Here there is no separate method to find the reactances value. So that is why I can take it X1 is equal to X2, approximately I can take it for the calculation purpose. In most of the motors, X1 and X2 dash are assumed as a equal values. Okay. So this can be used in our while performing the drawing of the circle diagram. You can observe this one. Okay. So otherwise they will give the what is the X1, what is the X2 values will give in problem. If it is not given, then you simply by 2 you can take it equal values. Okay. These are the tests, 3 tests essential to know the parameters of induction motor, whether it may be slip ring induction motor or squirrel induction motor. Okay. So in squirrel cage induction motor, this is a method. So how to do the slip ring induction motor, sir? So only simple thing. So in that case, we are going to use it rotor side, that should be the rotor resistance should be short circuited initially. How to that one? So we will see here. Okay. So we will see that one also. This is the squirrel cage, simple. So here the OC test, no? We will see the OC test on slip ring induction motor. Now same thing, So what is happened? The stator side 3-phase current, rotor side there is a windings, 3 windings will come. So what will happen? Rotor you start, you keep it, so is a starting and running condition, simply you keep the running position. That means 3, this one shorted, simply shorted, no resistance added in the rotor circuit, okay, simply shorted. So here what is that? Then give the similar connection, same you connect the W1, this is a W2, and just connect this one, you are connected this one, and this is connected here, and you connected the 1 ammeter, and this connected the 1 voltmeter, and this is connected to variac, and is connected with the ICTP switch. This is a method only. Okay, while in OC test, so the belt should be the loose and free to rotate, and give the same pressure, apply the rated voltage, then rotor will rotate at normal speed, then take the voltmeter reading, ammeter reading, W1 and W2. Okay, these are in steps are you taken the one reading. So we are going to get the OC test. In black rotor test, what we are going to tighten the belt, then same apply the rated current, then take the voltmeter reading, ammeter reading, and W1 and W2. Similar method, only you are changing these values. Okay, so what is the rotor? Here rotor resistance. Here what is happened? So from the slip rings we are going to get it outside. That means here, for example, you are connected. For example, you are going to get it. So for example, this one, you are connected here, this connected here, you connected. This is a rotor circuit. For example, you connected the delta connection in stator. Okay, the stator side, this rotor side, and it is coming the slip rings, from the slip rings. Now what is happened? You are connected one rotor you start, and it is connected terminals. Okay, it is connected here, and for example, you connected here, and it's connected here, for example. Okay, so just like now what is happened here, this resistance initially, and you are connected some resistance, here resistance F, it is keep this one. Now in this case what we have to do, keep in run position with the start position condition, start position. So start position, you are added the some resistance in series with the rotor circuit. Now in run position what will happen? Run position, so whatever the this 3-phase winding resistance, simply you taken it and shorted here. That means no resistance added in series with the rotor winding. So then how to start this motor? So that purpose I arranged this variac here, which will limit the starting current. Okay, so this is the starter and this is also starter. In this case I am going to bypass this one with help of short circuit run position. Okay, these are the some modifications you have to do while doing the experiment on this slip ring induction motor. Remaining is everything is same. Okay, so same test we are going to do it on slip ring induction motor also. Okay, so dear students, I think you have understood the how to do the no load test and black rotor test and rotor resistance test on given a induction motors, whether it may be squirrel cage induction motor and 3-phase induction motor. Okay, so let us summarize. So on this completion of this period, you have to able to know that the no load test, how to do the no load test, how to find the R0, X0, no load power factor and all values, and at the same time black rotor test, how to do the experiment and what are the values you are going to take it, and equivalent circuit parameters, how we are going to found, and the performance of the curves of black rotor test also we have calculated. At the same time rotor resistance, how we are going to find, we use the using the VI method. Okay. So, dear students, please go through your textbooks, and if face any difficulty, ask in next class. Okay. So, these are the tests regarding to the induction motor performance values. Okay. Thank you for listening my class.